Alright, hell yeah. So what we have here is the SAT, and this is the no calculator part of the math. So there's two math parts. I think there's two. This is no calculator. It's 25 minutes. We have 20 questions, so we're just going to be filling in the answers as we go. Now, we're going to take probably more than 25 minutes, because if there's cool stuff that I can share, we're going to do it. So, but, let's see if we can just do them fast. The graph models the radioactive decay, so we have hours, and then we have mass in milligrams. So sweet. So the mass is going down over time. So heck yeah, it could just run out of mass. Okay, hell yeah. And according to the graph at 5 hours right there, which of the following is closest to the mass in milligrams? Okay, so this is mass in milligrams. It's going to be 40. Okay, so hell yeah. So this problem is just if you can, like, I hate reading, or my comprehension is real bad. Like I'll just like read stuff and then I'll just like almost read the wrong things. I never know what they're actually asking. So this is one strategy. Just go for it. You know what I mean? Hey, what is it? What does it say? Find closest mass milligram sample at what? 5 hours. Cool. So, kind of working backwards is a very good strategy. And so we're going to say, hell yeah. This one's going to be C, and we can move on. All right, number 2. So we have this absolute value, x plus 3. Now, with absolute value, just if they confuse you, just get rid of it. You know what I mean? You can add it in later, especially if this was like, hey, absolute value of 3, greater than or equal to 6, you know what I mean? Just get rid of the greater than or equal, just make it equal, and then same thing for absolute value. So even just right here, what do we know? Okay, that just really pops out that x is 3. Sweet. So what is the... And then it just says, what is the positive solution to the given equation? See how, okay, so that was perfect. I didn't even read the question. I just kind of know what my strategies are. Anytime something looks funny, can I simplify it? And hell yeah, we can. And then so we're just going to say B. So that was pretty easy. Okay, hell yeah. So we're doing pretty good. And... okay, so we have this equation. Y is equal to 4 minus x. Now, you should, going into these things, you should definitely know that, y is equal to mx plus b, and you should rearrange this. You should say y is negative x plus 4, and then it kind of has this. So we know the graph has to go through 4, so these are just out, so just right away we're down to 2, and then we have a negative 1 slope. So it's going to be... And then, rise over run, you should just always say it. Slope is rise over run. But, it's going to really do you good if you know the equation of a line, just in general term. So what this says is we're going to go, and sometimes I don't, we don't work in rise over run. If we just have the y is equal to x, this equation, I'm just going to say, hey, I'm going to go over 1, up 1. But that's not slope. That's run. Oh, that's run over rise. If I said, hey, I go over 1 and then up 1, well, that's run over rise. You got to do rise over run. So we're going to go down 1 and then over 1. So that's and now did I get that right? Yeah, because or there's two different ways to do this. Holy Toledo! Because so let's do this. So we have slope is rise over run, and it's going to be negative. So we have, and it's going to be negative 1. Like basically, negative 1 is our slope. So slope is negative 1. That could be two things. It could be negative rise over run, or it could be rise over negative run. So let's do that. So let's start here. Just pick any point, and just the fact that you got to go in the y direction first is the headachy part. So we're going to go negative 1, and then we're going to go over 1. Cool. So this is my slope. Okay, now we're going to do this. We're going to do the same thing. We're going to rise up 1. Cool. But then we're going to go over negative 1. So booyah, both of these things get you there, and now we can totally see that the equation is going to be 1, 2, 3, 4. It's going to look like that. So this one's out, and that was good to take our time on that, because you got to go, at least SAT, the two things you got to know, equation of a line for sure, and then quadratic equation. Cool. So all right, let's move on to number 4. Oh, and just a second. So what did we get for that one? So we got answer is B on that one too. Okay, hell yeah. Okay, so number 4, we have two equations, and it says, what is the solution xy to the given system? Now, I'm old school, and I'm just learning about matrices. My brother gave me this book, Linear Algebra, so it's going to be hella cool. But I was just always like, hey, if y is this, I'm going to shove it right into there. But I do have a little bit better strategies. And instead of just writing it 15x minus 4 and then shoving it in, you know what I mean? Because that kind of gets a little bit tedious. You can do one step better. You can be like, well, let's multiply it by, if this is y, hey, what's 4y? Well, that's just going to be 28. Minus 16x. And then I can even do the negatives, because the negatives are my nemesis. So now I'm going to say, what's negative 4y? And you can think of this, it's always good to, like, hey, it's like factoring in it's like multiplying in a negative 1. If you think about that, hell yeah, negative 1 multiplied by 2.8. I mean 28. I think we can all do that. Negative 28. And then negative 1 multiplied by a negative 16 is positive 16. And then you can always rearrange later. This is also a good a skill to do. Just because if you don't like the way it looks, we'll just switch them. And then so we have that. So going forward, we know that negative 4y is this. And hell yeah. And then we're going to have 15 plus 16. That's going to be 31x. And then we're going to have negative 28 over here. If you can kind of do two steps at once, let's get this the hell over there. And so we're going to have positive 28. That's going to be 31. And then so we're going to, oh, sweet. So we're going to have 30, positive 31, x is 1. And so, yeah, x is 1, but then you got to go shove it into your equation and figure it out. So we're just going to do this. So we have 7 minus 4. Well, sweet, that's 3. And then booyah. There you go. So we have C. That was a pretty good way to do that one. All right, so moving on. Okay, hell yeah. So we have problem number 5. And again, look at this. All right, so we have less than or greater than. You know, just forget about it. Just do equals. Just to get a bearing on what's going on. You know what I mean? Because it's even equal to, hey, the solution that you would get by doing these. And oh yeah, and we probably should have gone back to this one. Let's do this one more time. And what's the easiest way? What's the better way probably to solve this? Whoa. Negative 4y is equal to 3. Well, I mean, I think the first thing is get all the terms on one side. So we're going to just do 4x plus y is equal to 7. See how we did that? You know what I mean? And then we have 15x minus 4y is equal to 3. Now, if you do this substitution method, or you know what I mean, you have to, like, you can add or subtract these. You can do whatever you want. What I think we should do is... well, I don't know. You can do either way. Sometimes subtraction, like, I don't know, mentally it messes me up in a pinch. But what we're going to do is multiply this by 4, so this becomes 16, and this becomes 28. And then this is positive 4, this is negative 4, so we're going to add them. And so this is going to be 0y. Hell yeah, it just goes away. You know what I mean? And then we're going to add them, so we have 31x, and then we have 31. And so you can really see x is equal to 1 just a lot faster. So let's use that strategy. So we're going to multiply this by 4, because that's going to give us 2x minus 24. And then we have to subtract these two, though. You know what I mean? Because we have 2x, and we're going to subtract by 2x. So we're going to have 0. So we're going to have y is equal to, and then it's going to be 3 subtract negative 24. That's 3 plus 24, it's 27. So y is 27. And then we can just quickly solve for x. If y is 27, we're going to subtract 3. That's going to be 24 divided by 2. So x is 12. Sorry, I almost messed that up. X is 12. So now, I mean, cool, it's got inequalities. That just might be like, who cares? You know what I mean? All right, so... Yeah, because this is going to be a solution. So if we say, hey, we got x, so we're going to go over 12 and then up 24. And unless I did something wrong, none of these work. You know what I mean? So because I can't go to x is 12 and then y is 27. That's not even a solution. So yeah, let's see if we made a mistake though. You know what I mean? So let's do this a different method. Let's solve for x. Or no, we already have y. So we're going to say y is 2x plus 3. We're going to throw it right there. So we have 2x plus 3 is equal to 1/2. Sometimes it's better to get into a fraction, minus 6. And then so when we subtract this over here, we're going to get, well, you could say 3/2. It's 1.5. Sometimes that's a hard fraction to do. But 2 minus 1/2, that's the same thing as 4 divided by 2 is 2. See that? And then we're going to subtract 1/2. So those are always kind of quick skills to have just so you don't make mistakes. You know, I mean, you could easily make a tiny mistake, you know, in there. And then we're going to say this is equal, we're going to get this to the other side. So this is going to be -9. Yeah, so we probably did really mess. How the hell did we mess up so bad? Let's go back to this, because we're multiplying this by 4. So 1/2 times 4 is 2. Cool. And then multiply this by 4. That's 24, right? That's always a hard one. Like 6 times 4 is also my nemesis, but another way to think of it is 12 times 2. Ever thought about that? And that's easily 24. I can totally see 12 times 2 is 24. It's really difficult for me to see that 6 times 4 is 24. Okay, and then what we're going to do, we're going to have to subtract these two. And so we're going to have 3 minus a -24. That's going to be 27. And that's going to... Oh, yeah, no, duh. I forgot to multiply this by 4. Okay, my bad. Yeah. So we just made our first just big error. You know what I mean? If I multiply this whole equation by 4... yeah, see, I don't do this method hardly at all. And that's why I'm trying to learn this linear algebra stuff. Yeah, I'm going to make a lot of mistakes. So anyway, so we multiply this by 4. And then when we subtract, we have 1 minus 4. That's -3y is equal to 27. Oh, man, this doesn't come out nice at all, does it? Yeah, but anyway, you know what I mean? Just I think in a pinch, just let's say we made a mistake or maybe we didn't. Doesn't really matter. So let's just move this to 28. So then we're gonna or what was 3? No. Holy hell! I'm really bad at arithmetic today. So yeah. It's 3 times 9 is 27. Sweet. And then so y is equal to 27 divided by -3. We're just going to divide this by... So anyway, so we have y is equal to -9. Hell yeah. And then we're going to throw that right into here. And we're going to have -9 minus 3. So that's going to be -12 divided by 2. That's going to be -6. So sweet. So yeah. So all these should jive. You know what I mean? So that's where I realized I for sure made an error, because there's no way all 4 of these graphs are just in left field. Okay, so we have -6, -9. So that one's cool. That one's cool. Yeah, they're all at the same location. So this is pretty good. So that would have been a crappy problem if all these graphs were just in the wrong location, and that would have been a trick question. But you know, if you're doing this fast and you can trust that, like, hey, this is the right answer, then the question just becomes, you know, I guess we got to figure out inequalities. Oh man, this is like what I'm the worst at, I think. So yeah, let's figure out what we need to do. So well, yeah, let's do this. So when y is -9, because we have that, y is -9 and x is -6. Is that what we got? Yep, x is -6. So we have, so 2 times -6 is -12 plus 3. And we're saying y is less than, so y can be any number less than -9. So y can be -10. Y can be -20. Okay, so sweet. So where can, and x can be equal to -6. So let's just go to -6 and then -20, and that should be a solution. And you can see, I'm just slow rolling this now that I got the answer. But hell yeah. So that's one way to do it, and I see that this one jives. So I don't know, you know what I mean? I'm really bad at inequalities, but that's one way to do it. It's just like, well, what does it even say? It says this y could be less than, whatever this number was. So y can actually be less than 2x plus 3. That's going to be negative 12 plus 3. Y can be less than negative 9. And less than negative 9 is a number like negative 10, negative 12, negative 20. Cool. And so we picked one that was obviously right there. And that was a struggle. You know what I mean? But hell yeah, we did it. Yeah, we even made a mistake going into it. And so yeah, it's D. Alright, hell yeah, we're not on a roll, but we're doing pretty decent, you know what I mean? I don't like tests because why try to, you know what I mean? If you had to do this, so let's do this. Let's just read the question. Avocados increase from these 2 years, how many million metric tons? And so this is in metric tons, I get it. In million metric tons, and the T is year after year. So sweet. So we're going to input. Whoa, you're not able to use a calculator for this one? This is in T years after 2000. So T is equal to 10 and T is equal to 11. Cool. So what's 17 times 10? You know what I mean? That's going to be 1.7. What's 17 times 11? I don't know. You know what I mean? You might have to do this, and you might have to go 7, 1, and then 0, and then 7, 1. And you're like, oh, yeah, no duh. Okay, we didn't make any mistakes, and this is going to be 1.87. Okay, but then we have 1.7 plus 2.54. And so we want to know the increase. So obviously this number is probably going to be lower. So we have... yeah, see, this is where, yeah, so we got 4.24, and we're going to increase to, we have this number, 1.87 plus 2.54. Yeah, nothing's nice on these. So we have 11, and then we have 9, 14, and then we have, so we have 4.41, and we increase 4.24. See, yeah, all this, this is just hell. There's nothing easy about it. You got to do this and that. And then, you know, what's 11 minus 4? I have no idea. But I know what 10 minus 3 is. That's 7. So 11, yeah, so it's 7. And then we got 1. So we got 0.17. And there you go. It's A. Whew, let's just be done with that one. But yeah, that was pretty good. We used the strategy of just reading the answer and then kind of going for it. So that was a pretty good strategy. And so we have answers A on that one. And all right, so which equation has no solution? All right, so one way to do this, just throw in 0. Well, what equation has no solution? I don't even know what that means. But let's just start doing these. 4x plus 4 is equal to 4x. Well, that can't have a solution. Because 0 don't work. Yeah, that's what I was thinking. I thought the first thing to do is just throw 0 in everywhere. So if you have, this is going to be 4 plus 4, that works. This is going to be 4 plus, well, you know, it doesn't mean, but yeah, I think if you have this, you can't have a solution. You can't. You just literally can't. So I think we get that. And let's try them all out. So we have 4x plus 4 is equal to 4x plus 4. Obviously, that's a solution. All right, same thing. 4x plus 4 is equal to x plus 1. Well, hell yeah, we got a solution. You know what I mean? And then 4x plus 4 is equal to x plus 4. So yeah, we get it, and it's D. All right. Hell yeah. That was a tricky one. Okay, number 8. So let's just read. It says, in the plane... Okay, so we're just kind of read, which is not an x-intercept of the graph. Oh, and I'm sorry, I don't even know what it says anymore. No, it just says x, so we have the function is x minus 1, and then this just wraps around x plus 1, and then x plus 2. So, and then which of the following is not an x-intercept? An x-intercept. Alright, so now here you go. This is going to be some like y is equal to, and you know, just in general, you have like you have x times x times x. With any polynomial, just like kind of ignore lower terms. Well, not if you're multiplying, but like once you get everything, I mean, essentially this is just x times x times x. So at the end of the day, this is really just y is equal to x cubed. And cool. And then so let's do this. So and if you kind of know what that is, it's going to maybe look like that. This is x, y is equal to x cubed. So if we, I don't know, what am I getting at? I have no idea. Oh, I guess I'm just saying, hey, this is the y term. Oh, I was just trying to make it simpler. Let's say it was a linear equation. I mean, you basically have the y over here, and then you have, yeah, I don't know what I'm getting at. But what does it say? What does it want? It wants to know which is not, and which of the following is not an x-intercept. So here's y and x. I think this is what I was getting at. So it has to go through this. So x has to be 0. So when x is 0, this function, so yeah, that's it. You know what I mean? So you just have to throw in x is 0, and yeah, these might have different solutions, because an x cubed could do this. So just know that an x cubed, so y is equal to x cubed, could dip across this 3 times. 1, 2, 3. So 3 of these might be correcto, and 1 might not be correct. Okay, so, oh, and this is a trippy one. Because sure, if x is, okay, and how this works is that, oh, shoot. Yeah. No. So, like, because of this, hey, look at this. Let's say this is our graph. This is 0, 0. Hey, over here is like -2, but the y-intercept is 0. So we inputted an x of -2. See, if we input -2 here, -2 plus 2, this becomes 0. So this is one of those where, like, let's just write it again. As like, so we're going to do y is equal to x minus 1, x plus 1, x plus 2. Now this, they want to know when this is 0. This is 0 when any of these products is 0. So this is really cool. This is why if you have like y is equal to 2x squared plus x, and then you want to make this equal to 0, you can't just factor out a 0. You can't just divide an x on both sides. You know what I mean? What you're supposed to do, and this is kind of like, I think, I watched like one red pen, blue pen. And then, yeah, that gentleman does a really good job of explaining this. It's just like, you can't do that. You can factor out an x, and so you'll factor out an x of this, so you're going to have 2x plus 1, and now this is equal to 0. And to satisfy, you know what I mean, hey, x could be 0 over here, and then this is 0. You know, if this is 0, 0 times any number is going to be 0. That's a check on reality. But this number could be 10, but hey, this number could be 0. So this could be -1/2. This could be whatever, well, I mean, obviously, if this is x and x, this could be -1/2, but this could be, to make -1 plus 1, this is 0. So those are your two solutions there. When you have a product, anything that's 0, the other thing can be whatever it wants. I mean, we obviously say if it, you know, whatever makes this 0, that's the same x that has to be over there, sure. But it just shows that you can have some number times 0 is equal to 0, or this is equal to 0 times some number, and that's also 0. So your solutions are 1. Your solution, so x equals 1, x equals -1, sorry, and then x equals -2. So we have 1, so we have x equals 1, that's a check. We have x equals -1, and we have x equals -2. So hell yeah, we've even just guessed it, and I don't know, you know, I mean, we got it. That was, I don't know, that was just kind of a guess, but we got it. So there you go. That was a pretty good explanation too. So we have D for that one. Now we're not trucking through this, but we're doing pretty decent. Okay, so, oh, these are my favorite, because I learn a lot from them. Alright, so we have which expression is equivalent to x to the 1/2 x. So let's learn a little bit, you know what I mean? Because what does this even mean? So we have x, and then let's get the x, you know, this also, 1/2 x. Sometimes it's confused. Is this x upstairs, downstairs, in the middle? You know what I mean? Well, it's upstairs, you know what I mean? So you have that. So now let's do that. We're going to have 16 to the x divided by 2. So now let's just do 16 to the 1/2. Now you might not know this, but this is the same thing as 16 to the 1 power Or what? Yeah, damn it. Yeah, no, this is the same thing as 16 to the 1 power, and then the square root, or the second root of, you know what I mean, of this. So let's say we had 16 to the 1 divided by 3. Well, that's going to be 16 to the 1, but then you're going to have the third root of 16. You know what I mean? So hell yeah. And then it's just like, hey, if we are doing that, if we're putting this 16 underneath like a square root or any sort of root, if it was a third root, you would want, let's say it was a fourth root. So let's do that. 16 1/4, that's going to be 16 to the 1. Now this is just an extra step. If this was 16 to the, I mean, it could be 16 to the 2 divided by 4, and you're going to be like, oh, that's weird, because what are we going to do? We're going to square 16 and then take the fourth root? Well, yeah, and now you can see that's going to be equivalent. Isn't that just 16 to the 1/2? Well, hell yeah, that's going to be 16 to the 1, and then the square root of 16. Square root of 16 is 4, so obviously this must be 4 too. So let's try that, you know what I mean? We have 36, 6, 9, and then we have 6, 1. And so we're going to have 12, and then 9, 10, 11. So we have 112. And then what do we have to do? We got to take the fourth root. What do you do to take the fourth root? Well, you start dividing, you start factoring this. So I do the easiest ones first. Let's just divide by 2. 112, maybe you don't know how to do 112 divided by 2. But let's do 100 divided by 2, that's 50. Oh, but you can obviously, it's 50 plus 6, so we get 56. We're going to divide this by 2. Same thing, I don't know how to divide this, but I do know how to divide 20. I know it's 20, 50 divided by 2 is 25. So it's going to be 28 because you're going to have 6 divided. Anyway, do you see that? And then again, you're going to divide this by 2. Well, that's going to be 14. That's an easy one to see. And then that's about, we could divide by 2 one more time, so we'd have 7. So it looks like we divided by 2, we divided by 2, we divided by 2. So we took, is that how many times we did it? So we did, and then the other thing to do is just like, hey, if I divided this by 2, you know, so we're going to say 112 is 2 times 56. And then once we divide by 2, we're going to say that's 2 times 2 times 28. That's the same thing. And then divided by 2, that's going to be 2 times 2 times 2 times 14. Okay, hell yeah. And then again, that's going to be 2 times 2 times 2 times 2 times 7. Okay, sweet. And then you can see that we have a fourth root here. You know what I mean? Because, yeah, and I don't want to get too ahead of myself, but if we have the fourth root of 112, and we just factored this out, that's the same thing as the fourth root of 2 times 2 times 2 times 2 times 7. But here's the extra step that's going to make your life a little bit golden, is we're going to say this. It's the fourth root of 2, because you can take this fourth root and do it to each one of these. And that's going to be the fourth root of 2 times the fourth root of 2, fourth root of 2, and then fourth root of 7. Okay, hell yeah. And, you know, I mean, just like if you have square root 2 times square root 2, that is 2. Well, you have to have 4 of these fourth roots to equal 2. So this is 2 fourth root 7. Now, and think we just kind of made up our own question. You know, we said what was, yeah, we were trying to do this one. You know what I mean? So, and how did we actually get the wrong answer? I think we did this part wrong. All right, let's chill it out. And I'm just going to pull out a calculator. 16 times 16. Yeah, we totally munched that. I don't know why we did. Oh, yeah, because we forgot the 0. Yeah, that's too bad. I'm pretty bad. That's why these no calculator ones are really good, because I'll just make hella mistakes. So this is 36, and now I have to, well, and then 9. But then I got to put a 0 here, and then say this is 6, 1. So my bad. And that's going to be 6. This is 15. That's going to be 256. So then if we do that same process, yeah, we were trying to prove that this is fourth root. 16 squared fourth root is the same thing as 4, so let's do that. So we have 256 divided by 2. Don't know how to do that, but 250 divided by 2 is 125. Plus, so it's going to be 128 if you see that. I don't know what this is, but I do know 28 divided by 2 is 14, so this is going to be 50 plus 14, that's going to be 64. Sweet, 64. This gets a little bit easier. That's going to be 32. And then we have 16. And do we need to go any farther? Well, we're doing the fourth root. Yeah, so I think we need to go far. So, and then divide by 2 again. That's going to be 8. Oh, this is faster. Hopefully I'm not messing up. 4th root of 16 squared should be the same thing as the square root of 16, which is 4, because that's going to be 16 to the 1/2. That's what we're trying to prove. I'm sorry I'm taking this tangent, but this is 8, no, this is cool. Yeah, because you got 4 and 2. So you just have a ton of things. We're going to, so we can say that 256 is 128 times 2. Or you can say it's 2 times 2 times 64. Or you can say it's 2 times 2 times 2, there's 3 of them, times 32. And do the same process, we're going to have 1, 2, 3, 4 times 16, 5 times 8, 5, 6 times 4, and then 2 times 2. Is that right? So we're going to have 2 times 2 is 4, times 2 is 8, 16, 32, 64, 128, 256. And we're taking the 4th root of this. Well, if we have 4 of them, 1, 2, 3, 4, and then we have 4 of those, and then we have 4 more, 1, 2, 3, 4. So this is just fascinating. It's like such the long road, but obviously I could do this to all of them, and I would have that 8 times. And a packet of 4 of those is going to be 2, and another packet of 4 is going to be 2, so hell yeah, that's going to be 4. Oh, that was atrocious, and sorry to do that to us. But these are just good to actually learn the basics. That is such a good place to have a learning moment. But now with that, let's try to do it as fast as possible. So we're going to say that this is 16 to the x divided by 2, and we're going to say, hell yeah, that's 16 to the x, and then the square root of 16. And so, oh, my bad. Let's see. Holy Toledo. So now they want to know, oh, shoot. Bummer. I'm going to take a pause. Alright, I didn't take any pause. But yeah, we should be able to, like, gut this one out. So yeah, this is 16 to the x divided by 2. Oh, and I guess you could do it in, oh, that's so fascinating. So I didn't know it has, like, is this what called the associative property? Like, because we were saying this was 16x, but then the square root of it, you know what I mean? We were taking 16x and then to the 1/2. That's the same, so that's what you can do. You can also say this is 16 to the 1/2 to the x. You know what I mean? Because that's the other property of these exponents. This is the same thing as 16 with the exponent of 1/2 times x. You know what I mean? And so, so yes. And then what I'm getting at is we tried to do it that way, and I was just like, oh, my mind melted. But you can do it the other way. This is the same thing as the square root of 16 to the x power. So hell yeah, that's just really 4x. Okay, so that was, I didn't know, yeah. I mean, I'm glad I played around with this a lot, but that was another one where it's just like, oh, I would have always taken the power first. You know what I mean? 16 to the x, and then the second root of that. But it's the same thing as the second root of 16, all to the x. That's the same thing. And then you can see this is 4 to the x. And now let's move on. All right, hell yeah. So that's A. All right. Booyah. Okay, so we have number 10. Okay, and again, let's just read that. What is the area in centimeters of trapezoid? All right, sweet. So this is going to be a pain in the butt. So trapezoid. This one is similar to that one. The length of each side of this one is going to be 3 times the length of that one. The area of this one is 6. And so, cool, we need to know about trapezoids. So if you have a trapezoid, you need to know that, hey, if you do this to a trapezoid, like the area... or, I guess there's a couple ways to do it. You could just do this to a trapezoid. Just lop it off right there and add it. So whatever this area is, then you're just good to go. And we're saying that this is 6 square centimeters. Now, I think you can put any, let's just put a height of 1 here. So we're going to say, hey, this has an average. And then this is where you get to an average, you know what I mean? So this length has to be 6. If this height is 1, this is 6 times 1. And, but let's say, and that's this length. But let's say we have this trapezoid. If this was 4 and this was 8, would that work? Hell yeah, because 8 plus 4 divided by 2. Having the equation of what's the average between two numbers is so good to have. You just add them and divide by 2, but that is a missing link in a lot of people's, just like equations that they would know, but it's just such a good one, that the average between these would be that. Sweet. And then so if we multiplied these by 3, we would have 12 and then 24. 8 times 3 is 24. Okay. And then what's halfway between? That's going to be 36 divided by 2. That's going to be, 15.5? Wait. 36 divided by 2 is 18. Oh yeah, because it's 15 and then plus 3. It's 18. Okay, so that would be the average of that. Now let's see if that makes sense if we just had a box that was 6 times 6 and then we increased it to 18. 3 times 3, that would be 18. Yes, so whatever we do to the square, we do to the trapezoid. And let's do one more. Let's say this height is 2 and this length is 3. And then so we're going to do, this is going to be 6 times 9. 6 times 9 is 54. Does that not work? Oh, that's a bummer. Why wouldn't that work? Oh, because we probably messed up our, I don't even know what we're doing. Oh yeah, check this. No? Well, let's see. So if this was 2, oh, my bad. So if this was 2, this height would be 3, but then the average length of these sides, it would be these sides that would, so like if this was our trapezoid, then let's make a trapezoid that's 1, and then and it would have to be let's say it was 1.5. It has to have an average of 3, so sometimes it's hard to work backwards. Dividing by 2, so it could be a total of 6. So we could say that this is, oh, bummer. This could be 4 and this could be 2. There you go. So if this was 4 and this was 2, and this had a height of 2, then we would have an average of 3, so we would have that 3 by 2, and then we would have an area of 6. Let's stay on this one, because this is fascinating to me. Did we actually get the answer anyway? It's just going to be, we found that the answer, if we took this, if we did a 6 by 1, and we tripled the lengths, we're going to have 18 by 1, so it's 18. So that's our answer. We're just trying to learn a little bit more about this problem. By making this 2, and it still should work out. So this box is going to be 4 by 2. No. This average length, this average length right here is going to be 3, and this height is going to be 2, so we get 6. So if we increase this by 3, so we would increase the lengths top and bottom by 3, and each length of each of the sides is 3 times the length. And I guess these lengths just increase by 3 also. I don't see that aspect, but anyway, we're just looking at the top and bottom. So we're going to increase the top by 3, it's going to be 6, and then the bottom is going to be 4 times 3, that's going to be 12. And then what's the area of this? The average is going to be 12 plus 6. That's going to be 18 divided by 2. That's an average of, oh, bummer. So why aren't we? Oh, yeah, that's an average of 9. And that's 3 times what our average over here. So we're going to have 9 times 2, and that's 18 again. All right, hell yeah. I'm going to, in my off time, probably not, figure out why these sides also increase by a length of 3. That's not intuitive for me, but I think we need to move on. Okay, hell yeah. So we have the function f is defined, and anytime you see this function, you know what I mean, just go back to like, hey, y is equal to this. And then what does it say? In the xy plane, the graph of in the xy plane, the graph of which of the following equation has no intercepts? Ah, this is wild. Because now you have to actually, it would be very good to say this is just x is x plus 1 squared minus 9. Like, not like revisiting these problems like 20 years later. Like, anytime it says f of x, that trips me out. You know what I mean? It's just this. I think that's, it looks like you're doing higher level math. You know what I mean? This makes sense because you're just taking this function and then throwing it in. Now this is going to be a new function, you know what I mean? So if we say that this is y is equal to this y is not equal to that y. You know, this is like maybe y prime. But then you could still do this. This y prime is equal to, but this is y evaluated at, oh, this is fascinating. Now what does this mean? Your x minus 2. Oh, so I think, yeah, the y is a function of x. So anywhere where you have x, you're actually just going to subtract 2. So that's weird. You know what I mean? So this, and should we FOIL this through? The fastest way to FOIL an x, you know, anything squared is just, hey, this is x squared plus 1 squared. That's going to be 1. And then we're going to have x times 1, but we're going to have 2 of them. So we're going to have plus 2x. That's the fastest way to do that. We can get it like this. Plus 1 minus 9 is going to be minus 8. So heck yeah. So if we did this is fascinating. Because now this says this is x minus 2 squared plus 2x minus 2 minus 8. And I think that's what this is saying. And it says which of the following has no x-intercept. So if this is an x-intercept, we know it's an x squared. Hey, it might just do that. And so if this was y is equal to x squared plus 1, hell yeah, it would be up 1, and it wouldn't have a y-intercept. Currently, this looks like an x squared minus 8. You know what I mean? So if we just see this, hey, it looks like it's going to be down here. So this one does work, but if we had the same function, minus 8, and then we subtracted more, well, it's definitely going to be down there, because it's going to be a y squared. Now, if it was a negative x squared, it's going to be like this, and then if it went through this intercept, so yeah, I think, just in general, I don't know this for certain, but is that you still have x squared plus b, you know what I mean, where this is where it goes through the y-intercept. Yeah. Alright, so if we had plus 11, that's going to be negative 9, but then plus 11, so this one won't work out, because, and I think this 2x just moves it side to side. I could be totally wrong, so let's dive into our calculator and do this one. Okay, so we're gonna, I think we should just just dive into our calculator, even though no calculators are allowed on this. We're just kind of learning. So this is going to be negative 8, but then we're going to add 11. Okay, and we're just going to graph that. Yeah, so it has no solutions. And this this positive 2x, yeah, I kind of remember that. It moves it opposite. It like moves it negative 2 in the x direction. So if we, and it doesn't even look like it moved it negative 2. That's kind of interesting. So 2x. But we can find the minimum. So let's just do that. Yeah, so the minimum is negative 1. I don't know. So yeah, I'll have to figure out. Alright, hell yeah. So we're back. But yeah, this will be something that I will have to figure out in my off time. Of just like, you know, how does this move the x squared around? You know what I mean? I guess if this is positive 2x, it's going to move it that way. Because let's do negative 2x and just see if it just moves it the other way. Yeah, it just moves it the other way. But it's just fascinating that it only moves at 1, so there must be a property there. Now, I think we should spend some time on this one because it just looks funky. So we're going to have, and we could do this in a different, we could just take this original equation. What's this y, this function, if we do it, it's going to look like this. We're going to have x minus 2, and then we're going to throw that in for x. That's basically what this is saying. F of x isn't f of x, it's f of x minus 2. So everywhere where we see x, we've got to throw that in. And so x minus 2 plus 1 is x minus 1. That squared, same rules, it's going to be x squared, 1 squared plus 1, but then we're going to have x times 1, that's negative x, we're going to have 2 of them. So we're going to have negative 2x. Sweet, so we're going to have that same, we don't need to rearrange this, we can just see, hey, it's going to be, it's going to have but then we have to minus 9. Sweet, so I guess we will rearrange it. X squared minus 2x minus 8. This will be negative 8, it'll be in this direction. And this negative, I guess, means that it's going to be shifted over that way. And it's only shifted over 1, I don't know that aspect. Is it just this divided by 2? Probably. Oh, yeah, now I get it. Because this drives it. Because if we have x minus 1 squared, oh, this is cool. So basically what this, yeah, if we have x minus 1 squared, this says whatever our x, and I guess, yeah, we do have negative 9. But this is going to say if we throw in, I don't know, I think this is what maybe drives that negative 1. I'm not going to say anything, but I would look into that aspect, just because when you do square this, it says x minus 1, and maybe that drives it that way. I have no idea. Okay, so cool, and we can do this one. So we're going to say x plus 2. Let's just do this one in our head. So x plus 2 is going to be x plus 3. So we're going to have x squared plus 9, because 3 squared is 9. And then you're going to have 3x, but you're going to have 2 of those. So you're going to have x squared plus 6x plus 9 minus 9. Okay, so yeah, that one is going to go through the 0. And then it's going to be shifted over. It's going to be probably to the negative 3. And let's see if we can do that. So now we're doing this mentally. We're doing x squared minus 6x, x squared minus 6x, and that's it. So it's probably going to be shifted. No, we said plus 6x. So it's probably going to be shifted over to the left. Yep. Oh, damn. It's way down there. I was not expecting that. Okay, so yeah, I fundamentally still don't understand x squareds. If you do have x squared plus 6, that obviously plus 6. But yes, this term definitely drives where the location is. Yep, so I'll have to figure out more about the middle term in an x squared polynomial, of how that shifts the graphs around. Yep. But yeah, this one is that's fascinating. And if we had x squared minus 2x, and then we just had negative 20, or just even negative 2, that's still just down. No, that's not down negative 2. So that is interesting. Yep. So yeah, I don't know anything about that middle term, of how that changes the equation. Yep. But I think it's spelled out. I don't think you need to FOIL this out. I think it's spelled out just in here, where if we because what we're going to have is we're going to have x minus 1 squared minus 9. That's the first one. The second one is going to be x plus 3 squared minus 9. These ones are going to be x plus 1 squared, but this is minus 20. And then we have x plus 1 squared, and then this is going to be plus 2. And so, Yep. And I guess what it says is if we throw in a 0 here, one of these won't have any solutions. You know what I mean? So that's kind of fascinating. Because if we bring this 9 over, if this is 3, we're good to go. Because 3 squared is equal to 9, so that's cool. If we throw this 9 over here, then this has to be 3 again, so x is 0. Sweet, that still crosses... or that still satisfies, and so if x is 0, it crosses, it's at least hitting this line. Yeah, so I mean, if you get a number that satisfies this equation, it crossed the x-intercept. So if we throw 20 over here, this would have to be, then we're looking, so x plus 1 just has to equal the square root of 20. And that's cool. We can make that happen. You know what I mean? But over here, we're going to have a negative 2. And then, you know what I mean? X plus 1 is equal to the square root of negative 2. And this is where you do not get a real solution. So I think this is where that kind of comes in. That you won't get a real solution. So let's type that one in. X plus 1 squared plus 2. Graph it. And it just doesn't cross the y-intercept. So that's another reason why this doesn't have a solution. Alright, hell yeah. I think we spent way too long on that one. So yeah, let's do this. Let's do problem 12. So we have in the xy plane, the graph of the given equation is a circle. Okay, so in the xy plane, so I mean, when they say xy, is just draw xy. And the graph of the given equation, oh, this equation. Okay, hell yeah. What is the area of this circle? Okay, so now we need to figure out, we need to know that the area of a circle is, if it's at the origin, is x squared plus y squared is equal to the radius squared. Now, this is another one of those equations you're just going to have to know going in. That x plus, and they usually use like k. I think they use k and another constant like k and j. But you could just say x origin, you know what I mean? And it's not plus. That's the thing that you got to memorize. It's x minus x origin squared plus y minus that y origin squared is equal to the radius squared. So wherever this circle, let's say this circle's 2 and then up 3, so that's going to be 2, 3, then this equation is going to be x minus 2 squared plus y minus 3 squared. Okay, so if this is down here, 1, 2, 3, and this is going to be 2, negative 3, then this becomes y minus negative 3. That's y plus 3. Sweet. But we'll do here, and then we'll do a circle. And at the end of the day, though, all they want to know is the area of this circle. So if we can just get this term right here, we're set. But we do have to... I think we probably do have to factor this one. So we're going to have x squared minus 10x. And if you even if you just started here, to factor this into a square, I think the fastest way to do this is like, hey, you're going to have an x, and then you're going to have this divided by 2. You know what I mean? I think if you can memorize that, and just double check yourself, because now if we square this... you know what I mean? And I don't do the foiling process. I just do it real fast. I say we're going to have this squared. We're going to have that squared. So that's going to be plus 25. And then we're going to have this plus that. And then we're going to have 2 of them. So we're going to have negative 10x. Cool. So we did it. The only term that we don't have is this 25. Sure, but we're going to add it in. You know what I mean? So we're going to say this is x minus 5 squared. We know that we have to add a 25, you know what I mean? And where is that going to come from? Well, just probably from over here. We're going to do the same thing with this y squared. Y squared minus 6y. So now can we do this fast? This is y minus 3. Hell yeah, because if we square it, and now you should square it, this is going to be x squared plus 9 minus, this times this, we're going to have 2 of them. So it's going to be negative 6. So sweet, so we have another plus 9. So doing this, we're going to have x minus 5 squared plus x minus 3 squared. Okay, so our coordinate is going to be 5, 1, 2, 3, 4, 5, and then up 3, 1, 2, 3. So that's the only thing is you got to mind these negatives and know that the equation for a circle has these negatives built in, but this x naught, y naught is your origin. Cool. All right, so, and again, we just need to know the radius, and this is going to be the radius squared. So, but we know that the area of a circle is pi r squared, so we don't need to convert the radius back to the radius. Or we don't need to take the square root of r squared when we use it in the equation, and it gives us it. So it shows pi. So it's just like, this is the high level way to do this. It's like, well, all you need to do is find that r squared, and I think we did. We had this 30, and so we had 30, but on this side, we had to add a 25. You know what I mean? And that means we had to add a 25 to that side. To make this a perfect square, we had to add 25. We got to add 25 both sides. To make this a perfect square, we had to add 9. So we're going to have 9 plus 25 is 34. Is that right? 34. And then we're going to add this. So this is going to be 64. So we have 64. Obviously, the square root, r squared. I'm sorry. But yeah, it's just 64. There you go. You don't have to take the square root of 64 and then square it. This would be a better problem if this turned out to be 62, because it would have kind of thrown you for a half of a loop. You're like, I don't know what the square root, I can't get my radius in a nice number, but oh yeah, the area is just that radius squared anyway. All right, so we have 12 is D. Booyah. And we didn't even write this one down. But as long as we didn't make a mistake, it's going to be that one, D. Cool. All right, so I'm going to take a short break, actually. All right, hell yeah. So we're back and just on to the next one. Dang, we got a lot more problems to do. But anyway, so we have x squared plus x divided by x. Now this is what I'm talking about. Like, hey, what drives this equation? It's an x squared. Just even forget about the x. So we have x squared divided. What drives this? It's x. So at the end of the day, we basically have kind of a linear equation, but it probably isn't. You know what I mean? Because, but I don't know. I think of it like that. It might be. I don't even know what this looks like, though. You know what I mean? But anyway, it might be kind of linear. But then it says, okay, let's just see what. But yeah, this x cannot be negative 5, because then you would divide by 0. If this x was negative 5, this whole thing would go to infinity. So yeah, that's where this definitely isn't linear. But I think after, as long as you're away from negative 5, like even this, I've not explored these, but if x is negative 5, 1, 2, 3, 4, 5, but if x, yeah, it's gonna be infinity on both sides. But let's say it's just anything besides that. Well, it might look like this. It might just look like x. And then once you get to negative 5, it goes to infinity. And then if you had negative 6, this would be negative. So then you would have negative infinity. You know what I mean? So then it would look like that. So sweet. So it still probably is a y equal x, but then something crazy just happens right there. That's the general gist of this, you know what I mean? And you might not know that from, like, even if you, yeah, so this is like kind of my take-home message, that I like to look at what the graph is, because there's only so many graphs out there, and then you can get kind of familiar with what a graph is. Yeah, I was just looking at my brother's, like, quantum physics stuff, and just like, well, all right, it's just hey, it's a graph where the area under the curve is 1 squared or something, you know what I mean? I think for quantum stuff, you have to take this 1, it's an area of 1, but it's squared to make the equation work, or something like that. Anyway, I don't know crap about quantum. But anyway, I tried to get little pieces as much as I can. Alright, so so the given expression can be rewritten as a plus 20 divided by x plus 5, where a is a polynomial, one of these. Which of the following represents a? Okay. Yeah, so sweet. what we'd probably do is oh shoot, because you could say this thing is just x squared divided by x plus 5 plus x divided by x plus 5. You know what I mean? So you see that? And then if we said this was 20, yes, I think this one's pretty easy. Because if we're saying that, hey, this, if this is, I guess just this top part is 20, then this would be 20 squared. So A would be, maybe that's not what they're saying. I mean, because obviously we don't have, oh, this is fascinating. Oh, I don't want to take a break on this one. Which of the following, alright, so so anyway, maybe we should just try one. So we're going to say, hey, x minus 4 plus 20 divided by x plus 5. So what we would do is we have to divide this by x plus 4. I mean, x plus 5. But if we do that, we have to multiply the top by x plus 5. So now this is going to be x squared. So I do have to FOIL this one. So we have x squared, negative 4x plus 5x. That's going to be plus x. And then we're going to have negative 20 plus 20. Sweet. So those cancel. And we have x squared plus x divided by x plus 5 is what we get. And so we just lucked out. And I think I'm just going to get on with life. You know what I mean? Because I don't know how to do that one from like an equation standpoint. But honestly, whatever we just did right there was what you would do in reverse, I think, to get like a generic answer. Yeah, that is fascinating. Yeah, so let's do that. To get this A, you would have to have x plus 5a divided by x plus 5. Cool, plus 20 divided by x plus 5. And then when you do this, then you could combine them. You would have ax plus 5a. Well, maybe, I don't know if you'd want to do that yet. Yeah, no, we should, I think. Holy Toledo. And then plus 20, and then this is all x plus 5, but then this top part has to equal x squared plus, so this top part has to be like that, so we're going to have x squared plus x is equal to ax plus 5a plus 20. Now, I'm just doing nonsense probably here, but x squared, and then we have plus x 1 minus a is equal to, yeah, I don't know how to work backwards on this one. Yeah, I'm not going to waste my time. I think we should just move on. Well, we got the answer is A. Okay, hell yeah. So number 14. An electrical circuit contains 3 capacitors in a particular, let's just read the question. Which equation correctly gives C in terms of D, E, and F? Okay, hell yeah. So we just got to pop C up top. Well, wouldn't we just multiply by, wouldn't we just, bring C up top over here? So we would have this. And then so we would have, so we would have 1, and then we would have to get this downstairs. So we would have 1 divided by D plus 1 divided by E plus 1 divided by F is equal to C. Okay, but what is all this? This is where you need to have a common, so, right here, if we wanted to add these two, if that's all we're focused on, we have to multiply this by E, and then this by E, and then we have to multiply this one by D, and this one by D. And then we can do that. So we can say E plus D divided by ED, because both of these are the same. But if we had to do this all in one go, we would multiply this by E, and then F. This one by D, and then F. And this one by E and D. Sweet. So we would have, and then we'll do them in order. We'll do, ED plus DF. I don't know why I'm caring about the order. How do they do it? DE, DF, EF. Yeah. And then plus EF. Okay, all divided by EDF. And they did DEF. Okay, DEF. Cool. So that's what we get downstairs. And this is 1 divided by that. So that's the same thing as reversing this. So we're going to have DEF upstairs, and then ED, DF, EF downstairs. So it's this one. Hell yeah, we did it. But yeah, that's a good one. You know what I mean? I think that's a good one. I think it's good to actually get C upstairs. That's the first thing. Get all this stuff downstairs, and then realize, oh, we need to kind of, do that little trickety trick. But then once you do, heck yeah, what did we get? Well, we got something upstairs and downstairs instead of just having 3 different things. Yeah, I don't know. Yeah, we just, I don't know. You know, I guess it's simplified a little bit. That's a skill that you're going to have in life. All right, sweet. All right, so 15, let's just read the answer. H is a positive integer. Bicycle, hours, dollars. Which of the following function represents the cost, so cost in dollars, of renting a bicycle for H hours? Okay, so let's just rent the bicycle for 1 hour. Cost of renting a bicycle is $8 for the first hour. Sweet. So let's just throw in 1 hour here, and we should get 8. This one's not 8. 1 hour. This one's not 8. 1 hour. We get 4 plus 8. That's not 8. Okay, we just rented it for 1 hour, and this has to be 8. It's D. You know what I mean? So you can play around with that one as much as you want, but that's going to be, I'm satisfied I did one fast. All right. What value of R, and let's see, the cost of renting a bicycle is $8 for the first hour plus 4. So let's rent it for 2 hours. So it's going to be, that's going to be 12. So it's going to be 16 minus 4. So that one would work. But it just, this one does work for that. It just doesn't work for the first one. You know what I mean? And this would be 16. That doesn't work. 2 would be 8 plus 8. That would work for, it would cost... No, it only costs $12. It costs $12, so that one doesn't work for 2 hours. This one does work for 2 hours, though. It just doesn't work for the first hour. All right, hell yeah. All right, moving on. What value of R is the solution to the given equation? Okay, so you just got to factor this, I think. So you go 3R plus 3, and then you got to subtract the 3R, so you're going to have 2R is equal to 3, and then... oh, you have to actually write these in. So R is 3/2, final answer. Sweet. So I'm just going to do it. So R is 3/2. And, you know what I mean? Should we, if this, yeah, let's double check. So if this was 3/2, it's good to do like a problem a different way. So 3/2 times 3, that's going to be 9/2. So that's going to be 4.5 plus 1, that's going to be 5.5. And then 5 times 3/2 is going to be, why are we messing this up? 5 times 3/2 is going to be 15 divided by 2, that's 7.5. And then, so what the hell do we have over here? Oh, 3 times 3 is 9/2, that's 4.5. Oh, but plus 3/2, no. Oh, plus 3. So we're going to have 5.5 plus 3. That's 8.5. That's still... Oh, why am I giving myself a headache on this one? So we're going to have 5R is equal to 3R plus 3. Subtract 3R, that's 2R is equal to 3. R is 3/2. R is just 1.5. So if we have 1.5... plus 1, that's 2.5, times 3, that's going to be like 6. plus 1.5. So that's 7.5. And then if we have 5 times 1.5, well, that's 5. And then plus 2. That's 7.5. I'm done with that one. I don't want to think about that one ever again in my life. Anyway, so what is the positive solution to the given equation? The positive solution. Sometimes, like, hey, throw in a 0. So this is my strategy for any polynomial. Throw in 1, 0, so 0, 1, negative 1. You know what I mean? 0. That's kind of my strategy. 0, 1, negative 1. If you throw in 0, well, hell no, it's not the same. But if you throw in 1, hey, you're going to have 3 squared, that's 9, and then you're going to have minus 12, and then minus 12, so that doesn't work. But let's throw in negative 1, you know what I mean? Because it's an x squared, so we're going to have negative 3 squared is still 9. This becomes positive 12. But this is a very good way to estimate. So let's slow down here. If we throw in 0, we get negative 12. So if we throw in 0, we get negative 12. If we throw in 1, we're going to get 9 minus 12. So we're going to get 9 minus 24, and that's a hell of a negative number. So if we throw in 1, we even get a bigger negative number. That's all I'm going for. If we throw in negative 1, we're going to get 9 here. Yeah, because negative 3 squared is 9. And then you're going to get positive 12 minus 12. So you're going to get, for negative 1, you're going to get positive 9. Now this gives you information. This says that there's a solution between like 0 and negative 1. So your solution might be negative 1/2 or something like that. Yeah. I mean, so your solution could be anything between 0 and negative 1. It might just be 1/3. I bet you it's negative 1/3. So, but it asks, what is the positive solution to the given equation? Okay, this is fascinating, because we found a negative solution. It just has to be. And then I guess, how would you graph this? Because we're saying that when we throw in x is 0, we're going to get y is negative 12. We're going to get that. But then when we throw in x is negative 1, well, heck yeah, we're going to get positive 9. So we're going to get that as a solution. It's going to cross right there. So I guess now we need to go the other direction. So this gave us an even bigger negative number. This is fascinating. And sometimes just throw in 10, because if we do 30 squared, well, that's going to be 100 times 9. That's 900. And then 10 is going to be negative 120, so minus 120. And then we're going to have, and that's basically going to drive it. You know what I mean? So we're going to have a positive number. If we throw in x is equal to 10, we're going to have a hell of a positive number. Sweet. So now we know that there, probably is a solution. Negative 1 actually provided a bigger negative number, but like even just 2, you know what I mean? So let's do, so we're going to have 6 squared. That's going to be 36. Minus 2 is going to be 6. This is going to be minus 24. And then minus 12. Okay, hell yeah. So negative 24 minus 12 is 36. So there it is. So our solution is x equals to 2. And I think this is a very good thing to do on really hard problems. If you're looking up the problems on the internet, just like, could I do that? Use the 0, 1, negative 1. See if you can figure out something. And then do negative 10, positive 10. And then, because, so that's basically, because let's go over this one more time. So I said that at 0 we had negative 12. At 1 we had even a lower negative number. But then at 10 out here we had a hugely positive number. So the only way to do that is to do that. You know what I mean? And sweet. And I guess 1, 2, it actually just goes right through here. And hell yeah, 10 was a hell of a positive number. It's going to be way up there. So that's going to be that. Now, okay, so I think we're done with this, but we will factor it. So 3x squared is going to be 9x squared. Minus 12x minus 12 is equal to 0. And yeah, now you need to factor this out. And you could do negative b plus or minus the square root of b squared minus 4ac. You're already going to have to know this for this test anyway. It's just if you can do this fast, and no one can. But anyway, so this is going to be 12 plus or minus the square root of 144 minus 4 times 9 is 36. 36 times 12. And I'm just going to forget about the negatives for a second. So we have 12, 6, 7, 0, let's not forget that, and then 6, 3. So we're going to have a 2, a 13, and a 4. So we have 432. That's why I don't like this method at all. And I think there's a better form of the quadratic that's not so, where you don't have to, you don't have to get such horrible numbers like this. So is this adding or subtracting? So we have negative 4, A is positive, C is negative. So it is going to be a positive 144, and so we're going to have 6, 7, 5. 5, 7, 6. Yeah, that's the bummer. You know what I mean? No one knows what the square root of that is. But I guess one way to do it is just, hey, 576 divided by 2. I don't know what that is, but I know it's 250. I don't know what 76 divided by 2 is, but I know 35 is 70, so it's going to be 38. So we're going to have, yeah, it's a tough one. It's 288. So we're going to have 288. Divide that by 2. We're going to have 144. And then we're going to have 50 and then 22, so it's going to be 72. And I probably already made a mistake, you know what I mean? Yeah, 35, that works, but 38. So it's going to be 288. Yeah, I'm satisfied. All right, so this is going to be 36, and then we're going to go down to, so now we're just money. Because now divide this by 2, we got, why can't I do this? 18? That's always a bizarre one to me. 18 and then 9. And so we're going to have, so we have 9 times 2, times 2, times 2, times 2, times 2, times 2, times 2. Did I do it? So 9 times 2 is 18, times 2 is 36, 72, 144, 288, 250, 256. We're taking the square root, so each of these, so we can say we have 18 square root of, 18 times 2 times 2 times 2. And, we have the square root of 18. And I probably already messed up. This is bumming me out. Yep. Yeah, I probably made a simple error here. I hate the quadratic. That's all I'm saying. Let's try it a different way, because I despise the quadratic equation. I think it's way too many steps, and none of them make sense at all. So let's do it where we complete the square. So the first thing that we do is we take this equation and divide by 9. So we're going to have x squared minus 12 divided by 9x and then we can do two steps at once. We got to get this to the other side, so that's going to be 12 divided by 9. Now we should figure out what 12 divided by 9 is. You know what I mean? This is going to be 3 times 3, and this is 3 times 4. So we have 4 divided by 3. So x squared minus 4 divided by 3x is equal to 4 divided by 3. Completing the square is x, and then we're going to have negative, and then we're going to have this divided by 2. That's 4, 6. Sweet. And when we do this, we're going to have x squared. But then we're going to have a positive 4, 6 squared. So that's going to be 4 squared divided by 6 squared. That's going to be 16 divided by 36. This ain't too bad, because we're going to say this is 2 times 8, and this is 2 times 18. So this is going to be 4 times 9, and I think we're good. So this is going to be 4 times 9. So we're going to have to add a 4 times 9 to each side. And what we should do, we should have kept this at 12 ninths. So now we're going to add 4 ninths. And now we're going to say this is 16 divided by 9. Cool. So this squares. And then we're going to take the square root of both sides. So we're going to have the square root of 16 over 9. And you can easily see, hey, this is the square root of 16 divided by the square root of 9. That's going to be 4/3. Okay, hell yeah, sweet. And then we're going to add 4/6 to this side. And so this is going to be 8/6 minus 4/6. And hell yeah, that's going to be 4/6. And then we have x is equal to 4/6. Is that right? Yeah, 4/6. And that's going to be 2/3. I feel like, why didn't we get the same answer? What did we think the positive root was? Was 12? What is the positive solution to the given equation? I think we did a really good job of doing that one, but I just think we made an error somewhere. All right, let's do that one again because I really like completing the square. I think it's like almost faster than the quadratic equation. Quadratic equation sucks if you don't have a calculator because you know, figuring out what's underneath that square root is just awful. Okay, so this is going to be 9x squared minus, let's see if I'm doing anything wrong here. 4 times 3 is 12. 12x minus 12 is equal to 0. So we're going to have x squared minus, yeah, we'll just keep it as 12 ninths, minus 12 ninths x. I don't know why I did that. But is equal to positive 12 ninths. Is that where I ran into my issue? I called that negative over there? I don't think so. Alright, hell yeah. Okay, so then we complete this square. We're going to have x minus 12/18. And now we should really simplify this. That's going to be 3 times 4, which is 3 times 2 times 2. That's 12. And this is going to be 2 times 9. So we can at least factor out a 2. We're going to have 6 ninths. Sweet. And, alright, so we're going to have minus 6 ninths. That's going to be squared. And so we're going to get a positive 36. Oh, hell yeah. So I see my error. I do this all the time. What was, yeah, 4/6 squared. I don't think it was this. I think we made a huge error there. I don't know why. But no, we have 6 ninths is the same thing as 2/3. Yeah, so this was 2/3. It wasn't 3. Yeah, no, we had 2/3 here. Oh, bummer. Holy Toledo. Okay, so maybe I'm just hallucinating. Okay, but 6 ninths is 2/3. So let's do that. And if we have 2/3 squared, 2/3 squared is going to be 4 divided by 9. Cool. So we have to add 4 ninths to both sides. Yeah. So yeah, we did this. And this is 2/3. So I think I made an error right here calling this x equals to 2. So let's slow down and just do that. So we're going to have, if this is 2, we're going to have 6 squared. That's 36. If this is 2, this is 6 times 4. That's negative 24, right? And then we have negative 12. So that's 36, minus 36. That should work. Okay, holy, where are we messing up? This is fascinating. Yeah, because you still add them to both sides. Because, yeah, when you square, even though this is negative. Oh, I think I maybe I subtracted. Yeah, so this was 4/3 minus 4/6. Hell no. We have to add that 4/6 to the other side. So that was my error there. Really apologize about this. So this is going to be 8. This is going to be, if we move this to 6, yeah, that's going to be 8, 6 plus 4/6. And we're going to have 12/6. Holy hell. Which is 2. So x is equal to 2. My bad. It's just so fascinating. But that's where my videos are really good, because we find our errors. And I think error finding is a better skill than problem solving. I think if you want to learn, I think I need to like look up more problem solutions more than trying problems. Alright, hell yeah. So we're back. The camera cut out, but I forget even what I was talking about, but for sure it was probably pretty cool. Okay, so next problem. We have 18. Alright, let's just read. What is the slope of line? Line J. Okay, so it says line J is not shown, but it's perpendicular to this. And then, so I don't know. You know, if your slope is 1/2, perpendicular is just to the -1. So that's going to be 1 to the -1. It's just flipped. It's 2 divided by 1. So if we can find the slope, and again, sometimes it's easier. I don't think we ever go down and up. I think we go over, like 1, 2, 3, 4, 5, and then we go down 2. You know what I mean? So, but just know that it's going to be rise over run. So it's going to be -2 divided by 5. So sometimes no one does this. No one goes down 2 and then over. We read books left to right, and then we go kind of up and down. Anyway, so then your slope is going to be just the opposite of that. It's going to be 5 divided by -2, which is -5/2. Okay, and that's one where we actually write in the answer. And we're on 18. We forgot to write in the answer the other one. So we have -2, nope, -5/2. And, yeah, that's fascinating. Well, holy Toledo. I don't know why it's not negative, though. I guess that is not the equation. You know what I mean? So if we do have something perpendicular, let's just friggin' draw it. There you go. So you could just do that, and then you're going to be over 2, 1, 2, 3, 4, 5. You know what I mean? So, yeah, my bad. We do have a positive slope, so it's going to be +5/2. I guess I don't know what I was talking about. I forget how perpendicular. I'm sure there's an equation there. But anyway, so we have down 2, 1, 2, 3, 4, 5. So we have a slope of -2/5. That was our slope. So we're going to have a +5/2. So sweet. So we're going to have +5/2. That's our answer for 18. What was our answer for 17? That was x is equal to 2. Sweet. Okay, and then we got 2 more. Heck yeah. All right, in the xy plane, I guess that's going to be like that. The graph is crazy, plus k, where k is a constant, has a y-intercept of 0, 2. What is the value of k? So, yeah, holy Toledo, let's figure this out. So we have 1/2 to the x. Okay, so we're going to have 0, but then we're going to have up 2. And, oh, check this out. So this is the equation. So when you throw in 0 here, you're going to have 1/2 to the 0. Sorry, 1/2 to the 0, that's just always, anything to the 0 is 1. As long as it's not 0 to the 0. If you have a number to the 0, that's 1. And then so you're going to have -14. But, and this y has to be 2. So you have -14 plus what equals 2. So you're going to have +16. Sweet. All right, done. +16. Sweet. All right, so the perimeter of a square inscribed in a circle. So it's going to be inscribed like that. Okay, so there's your diameter. You know, so there's your radius. So do some quick trigonometry. The perimeter of a square. So we're going to try to find these sides. So if this is side, you know what I mean? So then you have like A, B, and this is your C. So A squared plus B squared is equal to C squared. I don't even know what they're asking, but we can probably figure it out. We need to know what one of these sides are. A is equal to B. So you could, I don't know, I guess even just right now you could be like, hey, that's just 2 side squared. It's just 2 of those is equal to C squared. And you know C squared is just 2R, but we're going to square it. So that's going to be 4R squared. And you can see 2A squared is equal to 4, What are we trying to find? The side. So we're going to divide by 2. So we're going to have 1/2 r squared. And this is going to be equal to a squared. So a is the square root of this. So we're going to have 1 divided by the square root of 2 r squared. Alright, so it says the radius of the circle. Oh yeah, and that's the side. Holy Toledo. So if that's the side, I don't even know why I'm finding these things. I just kind of know, like, hey, that's something we could find. But it says the perimeter of the square is going to be 30. So, hey, this is one of the sides, and we're going to say 4a. So we have 4 divided by the square root of 2, r squared, is equal to 30. So we could divide by 3. So we're going to have 40 divided by 4 multiplied by the square root of 2. And then we're going to take the square root of that. That's going to be the radius. So the radius of the circle is, I probably messed up, but probably not. So this is going to be 15 divided by 2. So we have 15 divided by 2 times the square root of 2. Holy Toledo. Yeah, I probably totally messed up. Bummer. The radius of the circle is going to be some value of x times the square root of 2. Alright, let's slow this one down. Yeah, I think I just went just a little bit too fast there. Okay, so the perimeter of this square inscribed in a circle, we know that's the diameter, this is the radius, is going to be 30. Okay, and the perimeter of a square inscribed in a circle is 30 inches. The radius of the circle is x squared inches. Well, let's just maybe instead of saying radius, let's just do that. So we're just going to do it a different way, and now we can even just do this. We can just say, hey, this is r, and then what do we know about this? This is the square root of 2 times r. You know what I mean? That is one that you should have in your... No. Holy hell. No. This is 1 divided by the square root of 2 times r. That's what that is. And the square root of 2, you should always just know is 1.41. So if I have this is 1, this is 1, well, this is 1.4. Cool. Like, that's something you should have. And then if this is 1, well, what's the inverse? What's the square root of 2 but the inverse of that? That's going to be 1 divided by the square root of 2. That's going to be 1 divided by 1.4. And that is, you should just know this, it's 0.707. 1 divided by the square, that's going to be sine 45, cosine 45. It's just a good one to know going in. Okay, so hell yeah, so this is 0.707, but it's also 1 divided by the square root of 2. So if we're saying this is r, this is 1 divided by the square root of 2. But we're not saying it's r, we're going to say this is x square root of 2. So this side is just x. So sweet. So this side right here is x, and now we're just money. That was the trick, you know what I mean, right there. And you could have done it for 2r, but it's just real nice to do it like that. And then you can see that, hey, this is x, and we're going to have 1, 2, 3, 4, 5, 6, 7, 8. Oh, and maybe I messed up. Did I say this only? Yeah, did I say? No, I said it had 4 sides. But anyway, so now it's going to have 8 of these x. So 8x is equal to 30, and x is 30 divided by 8. So yeah, I'm sure this probably could work out where this is the radius right here. But we're going to say it's x square root of 2. So we would divide this by the square root of 2. And, oh, so yeah, we could probably do that. Okay, so this, I don't, yeah, I mean, this is the last problem, so why don't we? This is going to be the square root of 15 divided by the square root of 2 And then this is going to be the square root of 2 square root of 2. That's the same thing. Cubed root of the fourth root of 2 is the same thing as the square root of 2 square root of 2. Alright, so this is kind of what we have. One of these cancels, and then we have the square root of 15. Yeah, no, I think I made a critical error on this one. At some point, I think I did. I just don't know where. And I'm just not. I don't think I'm willing to. I mean, yeah, we might as well, because that was the last answer, and we got our answer is going to be 30 divided by 8. Sorry about that. 30. That's going to be 15 divided by 4. Okay, so our answer for this one is x is 15 divided by 4. Okay, hell yeah. And I guess, sure, we're going to go over the answers just to see how many I did wrong, but let's try to do this one. You know what I mean? From that perspective that I wanted to. So we're going to take this circle, inscribe the square, say that this is the radius, so we have 2 of those. We know that a squared plus, and we're going to call this a and a squared plus a squared, that's going to be 2a squared is equal to 2 times the radius squared. So this is 4r squared, and then 2a squared. Okay, so a squared is equal to 2r squared, and then a is the square root of 2, and then just, oh, this is probably where I messed up. Yeah, I didn't do this. I didn't just bring that down to r. Maybe. I have no idea. Okay, but anyway, so the side is going to be the square root of 2r. It already says the radius of the circle, r, is x square root of 2. So this is one of those prime places where we could have thrown it in right here and just say, hey, r is the radius of the circle is x square root of 2. Yeah, so it's going to be x square root of 2. This is going to be 2x. So a is equal to 2x. So at least let's double check our answer. And so that's going to be 2x. And so we're going to say that 2x, but times 4 of those is going to be 30. So we have 8x is equal to 30, and then we have x is equal to 30 divided by 8. That's going to be 15/4. Sweet. So we double checked it there. But let's say we didn't want to do that. So we got down to a is the square root of 2r, and this is where I just decided to say, hey, well, we have 4 of these. I don't know where I made my mistake. It was, oh yeah, I thought this was 1/2. That was really dumb of me. I apologize. Yeah, I thought this was 1/2, and then I don't even know what I did. I went left field. So sorry about that. Somewhere I just totally lost track of reality. Okay, so we have this, and then we're just going to say 4 times a is 30, which is 4 times the square root of 2r. So now we have r is equal to 30 divided by 4 divided by the square root of 2, and that's going to be 15/2 square root of 2r. But then we can say r is equal to x square root of 2. That's what they say. And then so we can say 15 divided by 2 square root of 2. This 2 square root of 2 can pop upstairs, so we have x square root of 2 square root of 2. That just becomes 2x, x times 2. This is 15 divided by 2 after that, and this is 15 divided by 2. So we can bring, I guess we just bring this 2 downstairs. You could have bring this 2 upstairs, or you'd say 4x is equal to 15, or you could just say x is equal to 15 divided by 4. Okay, holy hell. So yeah, just somewhere right in here just made critical error. Alright, sweet. So now we're going to take a look at the solutions. I have to actually go upstairs and go get those solutions. Alright, hell yeah. So here, this is the calculator solutions. We might do that at a later date, but might as well just cover those up. So anyway, no calculator solutions, and heck yeah, C, 2 B's, a C. Oh, so we got one wrong, so 5. So we need to go back and do number 5. Alright, hell yeah. A, 2 D's, and A. Oh, sweet, we got number 10 wrong. No, I enjoy getting wrong answers, you know what I mean? Because then yeah, I would rather get wrong answers than right answers sometimes. Anyway, 3 halves, 2, 5 halves, 16, 15 fourths. Okay, hell yeah. So we get to go back and do a couple of these. So yeah, we messed up number 5. Okay, yeah, because inequalities. Yeah, I don't know. Why didn't that work? Yeah, that was fascinating. I thought for sure that would work. So it must be A. Let's see, what is it? So we have number 5. Number 5 is B. All right, so number 5 is right here. So let's figure out why that is. So we have y. Let's just pick a value. So y is going to be 0. And is that less than 3? Yeah, 0 is less than 3. Sweet. So now let's go over here and choose this. Yeah. Oh, so yeah, this fits. You know, you should always choose the 0 point, you know, first. You know, yeah, so that's a good strategy. Because if I choose the 0 point, 0y, 0x. So I'm saying 0 is less than 3. Cool. And then so that should be a solution. It's not in that one, and that one. So yeah, that's fascinating. So even though this was a solution, no, maybe this wasn't a solution. So yeah, let's try this. So we were going to go -5. Let's just do that. -5, -10. Okay, so x is -5, y is -10. And so we have -10. So -5 times 2 is, yeah, -10 plus 3 though, where this isn't less than and equal to that. So that one, that value does not work. Yep. But I think I'm done with this one. I hate inequalities. Maybe I'll do them later. But even just choosing 0 worked out. Because if we have 0, is 0 greater than -6? Yes. So that checks out. So this 0 should be a solution. And it's only a solution in B. So that'd probably be the fastest way to get there. Okay, so number 10 was the other one that we got wrong. All right, hell yeah. And I think I have a good strategy on how to, you know what I mean, kind of figure this one out. So let's grab another sheet of paper. I think that what we should do on this one is just not make it a trapezoid. So we're just going to call it a square. And I see my error here. Holy hell. Because even if I said this was 6 and this was 1, and it says yeah, that's where I just didn't want to get into this angle. I was just like, nah, no thanks. But I could have. I mean, I already simplified it down to a square. I just increased this side. I did not increase the other side. So we would have 1 times 3. So we would have 18 times 3. And the answer would be 354. So the answer should be C. And number 10, it's number 10. The answer is C. So yeah, so for this trapezoid question, just know that a trapezoid is very similar to a square. Even if they had this as a triangle question, I bet you could just turn the triangle into a square and then just at the end of the day divide by 2. But we're going to turn the trapezoid into a square. And if we say, hey, this is a trapezoid with an area of 6 square inches. Now we're going to increase the length of 3 on all of them. So we're going to go 18 by 3 by 18. So we have 3 and 18, and then we get 54. All right, so I'm glad I made those 2 mistakes. And I guess I see where I made them. So but that was pretty good. You know what I mean? 2 mistakes, and I love mistakes. I would have rather, yeah, I'd be happy to make 5 mistakes on this. Anyway, so hell yeah. So thanks for joining me on this one. And hopefully we'll do the one with the calculator. There's more problems here. It's supposed to take 55 minutes. But yeah. All right, thanks for joining me, and that's the video.